Second day of class notes, Simpson paradox. Sometimes it is inappropriate to average proportions. For example, suppose you are a baseball player and need to choose a hitter for a certain situation. Player A has 103 hits at bat, and player B has 45 hits and 151 at bats. It seems obvious that player A would be the better choice. However, against right-handed pitchers, player A has 28 hits and 81 at bats, and player B has 12 hits and 32 at bats. Now, player B seems better in this case. So if you look, player A, for overall, player A seems better. However, versus right-handed pitchers, player B is better. But if you go to left-handed pitchers, player B is also better. Well, that's weird. How can player B be better for right-handed pitchers and left-handed pitchers, but not better overall? This is the Simpson's paradox. And this is because hitting against left-handed pitchers is more difficult. And even though player B is better in both cases, since player B has many more at-bats against left-handed pitchers, his overall average is lower. Fortunately, Simpson's paradox is fairly rare. Another example of this with two pilots can be found on page 35 in your book. Bottom line, think about it. Sometimes the Simpson's paradox occurs when you average things, such as established people, the population, and the elevation, to get an average that really doesn't make sense. Alright, so for your homework, you know you had to read chapter 4, page 44 to 56. The following are the rest of the notes that you need, and then make sure that this homework is done, except for questions. There are several good ways to display the distribution of a quantitative variable. The most basic way is called a dot plot. Here is an example using the heights of 50 students. In fact, let me try to turn this.